All right, so this is the second video in a series of 3 on graphing quadratics, okay, quick graphs of quadratics. In the first video, we discussed, what the graphs of a quadratic function look like, the minimum and the maximum value, and we went over specifically quadratic equations that are in vertex form, all right? In this video, we're going to go over quadratic equations that are in standard form, which is y equals ax squared plus bx plus c. Okay, some of the stuff from the first video is going to carry over to this, okay? Specifically this first bullet point. So if a is positive, okay, you're going to have a parabola that opens upward and the graph is going to have a minimum value, all right? If a is negative, you're going to have a parabola that opens downward and the graph is going to have a maximum value, okay? And the y-coordinate of the vertex, as before, is going to be the maximum or minimum value, whatever that is, okay? So in vertex form, you could pull the coordinates of the vertex right from the equation, okay? So you can pull a value from the equation this time as well, but it's not going to be the vertex. It's going to be the y-intercept. So the y-intercept is going to be this constant c at the end of the quadratic equation in standard form, okay? Just like in slope-intercept form, the constant at the end was the y-intercept for the line. In quadratic equation in standard form, the constant is going to be the y-intercept as well for the parabola, okay? So because of that, because we can't just pull the vertex right from the equation, we actually have to do a little work to find the vertex, okay? So the x-coordinate of the vertex is always going to be the opposite of b over 2a, okay? The opposite of b over 2a, all right? So as before, once you have the x-coordinate of the vertex, you have the axis of symmetry. Okay, you have the axis of symmetry. It's going to be that x equals that negative b over 2a as well, okay? Well, here's where the work comes in. To find the y-coordinate of the vertex, you're actually going to have to plug the x value that you got for the vertex into the equation and solve. So there's a little bit of work there, okay? Once you do that, you've got a y-intercept, you've got a vertex. Remember, we're doing quick graphs here. We could make a table of values to make our graph a little more exact. We could, find the x-intercepts, if possible, by solving the substitution, by substituting 0 in for y and solving the resulting equation. Some of those are going to take work, okay? We're trying to do quick graphs here. So with the y-intercept and with the vertex, hopefully we've got enough information to graph the parabola. If we don't, then you're going to have to find more points. Either find the x-intercepts or use a table of values, okay? And as always, we can use the axis of symmetry and that concept of symmetry to help us draw the graph more quickly, okay? All right, so we've got our equation. It's f of x equals negative 1/2 x squared minus 2x plus 6, okay? So a equals negative 1/2. That leading coefficient is negative 1/2, all right? So a is negative. Because a is negative, I know the parabola opens downward, which means I have a maximum value, okay? The vertex. A is negative 1/2, B is negative 2. So I have to use my little value here, x equals negative b over 2a. So let's plug those in. So the vertex x-coordinate is negative b, so negative 2 over 2 times a, 2 times negative 1/2, okay? So in the numerator, when I clean that up, I get a positive 2. In the denominator, when I clean that up, 2 times a negative 1/2 is negative 1. So I get 2 over negative 1, which simplifies and gives me an x-coordinate of negative 2. Okay? All right. So the axis of symmetry is going to be the vertical line through x equals negative 2. All right. Now, the vertex y-coordinate. I'm going to take my vertex x, and I'm going to plug it back into the original equation, like this. All right, so let's follow order of operations. I'm going to square this negative 2. So that's going to give me negative 1/2 times 4. I'm going to multiply negative 2 times negative 2 here, and I get 4. Okay, so let's keep cleaning up here. I've got to multiply negative 1/2 times 4. That gives me negative 2. 4 plus 6 added to be 10. And when I combine that negative 2 and that 10, I get 8. Okay, so my y-coordinate of my vertex is 8. So that makes my vertex negative 2, comma 8. So negative 2, comma 8. All right. Because my vertex y coordinate is 8, that's where the maximum value occurs. The maximum value is 8, and it occurs when x equals -2. Okay? All right, one last thing to find before we graph this. The y-intercept, remember the y-intercept was that c value. It's that constant at the end of the function. Okay, so the y-intercept here is going to be 6 because c equals 6. And now I've got enough, okay, to graph this without using a table of values, without finding the x-intercepts. Okay, so let's move on over to the graph. All right, so we had our vertex at -2, 8. Remember, we had our axis of symmetry was the vertical line through that point, okay? And the other value we found was the y-intercept, which we found to be at 0, 6, okay? All right, now we can use the axis of symmetry here. We know this point is 2 units to the right of the axis of symmetry, so I can use the concept of symmetry, and I'm going to have a point on the other side of the axis of symmetry 2 units to the left of that vertex, okay? 2 units to the left of that vertical line, okay? So the coordinates for that point would be -4, 6, okay? If you want to be a little more exact again, make a table of values, okay? Or find the x-intercepts here. The x-intercepts would be -6 and +2 if you were to solve that equation by factoring, okay? But I want to do these relatively quickly, so our parabola should go through all those points we found. And notice I've got them going through the x-intercepts at -6 and +2 as well. So that's what the graph of this quadratic function looks like. Again, notice the maximum value up here at 8. The highest y-coordinate is 8. That's why it's a maximum value, okay? So that's a quick graph of a quadratic function using standard form.